Why Earth's rotation is speeding up this summer. This summer, you might notice a strange phenomenon. Days could be shorter than usual, and it's likely to happen again in August. But here's where it gets controversial. Why does the Earth's rotation speed matter to us? Let's break it down. The reason lies in the moon's position. For a few days this summer, Earth will spin just over a millisecond faster than normal. On July 22nd, the day might be 1.34 milliseconds shorter than 24 hours, and August 5th could be 1.25 milliseconds shorter. However, the shortest day of the year is expected to be July 10th, which trailed the standard day length by 1.36 milliseconds, though this record isn't confirmed yet. Scientists tacked tiny changes using atomic clocks to ensure technologies like computers, GPS, and telescopes stay accurate. But for most people, a millisecond is invisible. As geophysicist Duncan Adnute explains, since we're talking about 1 millisecond, it's not something you notice. These shorter days occur because the moon is farther from the equator on those days, weakening its gravitational pull on Earth. When the moon aligns with the equator, it pulls harder on tides, slowing Earth's spin. But this time, the moon's distance is causing Earth to rotate faster. Fun fact, the shortest day on record was July 5th, 2024, when Earth spun 1.66 milliseconds slower than usual. This fluctuation is seasonal, with shortest days typically falling in summer, July-August. But the moon isn't the only factor. Earth's inner core movements and climate changes also influence its rotation. It's an extremely difficult problem to untangle all the contributing factors, says NASA geophysicist Surendra Adhikari. Historically, Earth's rotation has varied, but since 2020, scientists have observed a quickening trend. However, experts predict a slowdown will eventually take over, though acceleration might persist for decades. Over billions of years, Earth's day has been longer. During the Proterozoic era, days were as short as 19 hours, and late Cretaceous dinosaurs might have experienced 23.5-hour days. Today, these fluctuations are managed through leap seconds added to Coordinated Universal Time, UTC, to keep clocks aligned with this rotation. Since 1972, 27 leap seconds have been added, with the last in 2016. But with advanced technology, the leap second system may become obsolete by 2035. Experts argue atomic clocks and computer networks are now far more accurate, but they still need to sync with the older UTC system. Some researchers are even considering removing a second from UTC around 2029, a move critics call risky, comparing it to the Y2K anxiety. What if our tech can't handle the change? As meteorologists worldwide debate this, it's possible global timekeepers might ban the move before it happens. Or we might see a day skip a second. And to most of us, that lost time will be imperceptible. But here's the part most people miss. While these changes are tiny, they'll highlight a bigger question. Should we still rely on a system designed for a slower Earth? What happens when our technology outpaces the planet's natural rhythm? Let us know your thoughts in the comments. What do you think about removing a leap second or keeping the system as is? Earth's shortest days ever. Why our planet is spinning faster in 2025. Hold on to your hats. This summer has rewritten the record books in a way most people won't even notice. While the Northern Hemisphere is soaking up summer's golden light, they're unknowingly living through some of the shortest days in modern history by a sliver of a millisecond. But here's where it gets controversial. Scientists are scrambling to explain why Earth's rotation is suddenly spinning faster and whether this could disrupt the technologies we rely on daily. Let's dive into the science, the surprises, and the questions that keep experts up at night. On July 9th, Earth completed a full rotation 1.34 milliseconds faster than the standard 24-hour cycle, according to the International Earth Rotation and Reference System Service, IERS, and the U.S. Naval Observatory. This summer alone will see two more record-breaking days, July 22nd and August 5th. While these differences are minuscule, they're part of a broader trend. Over the past 5 years, the average length of the day has been shrinking, occasionally dipping below 24 hours. Nicholas Stamatakos, an astronomer at the U.S. Naval Observatory, called it a remarkable shift that's puzzling even seasoned researchers. So what's causing Earth to spin like a cosmic ice skater tightening her stance? The answer lies in a chaotic mix of forces. The moon's gravitational tides, for instance, act like a cosmic brake. Twice a month, when it aligns near the equator, it slows for its rotation. But when it shifts toward the poles, it gives the planet a nudge to spin faster. Meanwhile, Earth's atmosphere plays a role too. During summer, the jet stream slowdown forces the planet to compensate by spinning quicker, much like how a spinning top speeds up when its weight shifts inward. And then there's the planet's core. For the past 50 years, Earth's molten inner core has been decelerating, yet the surface above is spinning faster to conserve angular momentum. Geophysicist Duncan Agnew calls this a mystery we can't yet solve. What's driving the core slowdown? Could it reverse? These are questions with no easy answers. We're flying blind here, he admits. Are these the shortest days in Earth's history? Not even close. Fossilized coral and mollusk shells reveal that 70 million years ago, a day lasted just 23.5 hours. 400 million years ago, days were a mere 21 hours long. The moon's tidal pull has been steadily stretching out our days for billions of years. But short-term fluctuations, those are wilder. Agnew notes that the 1820s and 1860s saw even shorter days than today. That the Earth's rhythm is anything but steady, he says. Will you feel these millisecond shifts? Probably not. A blink of an eye takes 100 to 400 milliseconds, so a 1 millisecond day is imperceptible to humans. But for astronomers and tech systems, it's a big deal. Astronomers rely on precise timekeeping to track celestial events. Tiny errors can throw off calculations by light years. To keep the atomic clocks in sync with Earth's unpredictable rotation, timekeepers add or subtract leap seconds. Since 1972, 27 leap seconds have been added, but by 2029, the first ever negative leap second might be introduced to slow down atomic time. Software engineers are already bracing for chaos, as past leap second adjustments have crashed systems and disrupted GPS networks. Climate change could further complicate things. Melting ice caps, rising seas, and groundwater depletion are redistributing Earth's mass, which could slow its rotation over time, like an ice skater extending her arms to slow down. Yet these effects are subtle and counteract the current acceleration. Stamatakos warns that predicting Earth's rotation beyond 6 months is like forecasting the weather in a hurricane. So, will the sun continue to rise at the same time tomorrow? Maybe, maybe not. The Earth's dance with time is a delicate, ever-changing waltz. And as for the leap second debate, should we keep adjusting our clocks to match Earth's winds, or let technology redefine time on its own terms? Share your thoughts below. Do you think we're overcomplicating timekeeping, or is this a problem worth solving? Why today is shorter. The science behind Earth's rotation. Imagine waking up one morning to find that the day has been shortened by a fraction of a second. Sounds like science fiction, right? But here's the astonishing truth. Scientists have predicted that today will be slightly shorter than normal. The reason behind this phenomenon lies in the Earth's rotation, which is influenced by a multitude of factors, including tiny variations in the weather, tides, and even the liquid inside the Earth's core. The International Earth Rotation and Reference Systems Service, which measures the Earth's rotation and forecasts the length of the day, has predicted that July 22nd could come out about a millisecond short of a standard 24-hour spin. But what's really interesting is that this isn't an isolated incident. The Earth's rotation has been known to vary for about 100 years, and recent headlines have been hyping freakishly short days in July and August. So, what's behind these speedy spins? According to Dennis McCarthy, the former director of time at the U.S. Naval Observatory, the speed of the planet's spin gets influenced by all kinds of factors, including the gravitational influence of the moon, the effect of winds and the atmosphere, plus the movements of the Earth's liquid core. Here's where it gets controversial. Some scientists believe that human-induced climate change could eventually become the dominant driver of changes to daylight, surpassing the moon's gravitational pull. This is because climate change is melting ice at the poles and sending water down to the equator, slowing the rotation down. The researchers believe that this effect is already lengthening the days, and some have even calculated that in a worst-case scenario, climate change could eventually redistribute water in a way that would make the days milliseconds longer. And this is the part most people miss. Understanding and being able to predict the precise rotation of the Earth is crucial for all kinds of applications, from launching missiles to navigation to high-tech farming. At the equator, in 1 second, the Earth will rotate the length of 4 football fields, says Nick Stamatakos, head of the Earth Orientation Department at the U.S. Naval Observatory. The Earth's moving pretty fast, he says, so any little variations will accumulate, and it's an issue. By looking at the recent rotation history, along with information about weather systems and long-term patterns, researchers can make predictions about how the Earth will spin on any given day. These predictions generally get less accurate the farther out they go. So, what do you think? Will human-induced climate change become the dominant driver of changes to day length? Share your thoughts in the comments below.